My name is Craig Risien. I'm a faculty research assistant at the Oregon State University in the College of Oceanic and Atmospheric Earth, Ocean and Atmospheric Sciences. And I work on the Ocean Observatories Initiative, mooring technician. We have moorings off the Oregon coast and the Washington coast, 2 arrays of moorings. We measure a whole host of things, including conductivity, temperature, depth, the CTD measurements. You can get salinity and density, but we also measure dissolved oxygen and pH. We measure water velocities, all these sorts of things. We also measure, we have bioacoustic sonars, which is pictured here. So what you're seeing here is a bioacoustic sonar that sits off of Oregon. It looks up from about 200 meters and it sends sound through the water column, and that sound kind of bounces off stuff in the water column. And so what you see here in the greens, yellows, reds, here's the surface here, you can see that return. But in the greens and the reds, you can see zooplankton. And what happens at sunset, you can see the sun here, so day, night. At sunset, the zooplankton rise to the surface where they feed, and at sunrise, they descend down to about 200 meters where they shelter in place, avoid predators. And you can see that happens every day and every night. What we saw during the solar eclipse, pictured here, where you can see the sunlight went to zero, where these zooplankton ended up, well, they thought that it was, I guess, nighttime. So they came up about 50, 60 meters, and then they realized as the sun started coming out again, that it was actually better for them to go down, so they descended down to 200 meters again, waiting for night. So they kind of got fooled here by the eclipse as they went up 50, 60 meters and had to descend again. That's it.
Thank you. Great. Thanks so much.
Yeah, no problem. You're welcome.
Any little tips for middle schoolers? What should they do for school and for life?
The mathematics is important. In all of this work, opportunities to really, there's a lot of mathematics, and programming is really important. These data sets are big, and oftentimes programming really helps kind of manage the data and get us to kind of break it up into little pieces, bite-sized pieces. We have to do a lot of programming. So opportunities to get involved in computer science and mathematics, there's a lot of physics involved. All of those things really help you become an oceanographer, a physical oceanographer.